All right, so we are going to do a stations lab today where we're going to see 6 different types of reactions. We're going to see single replacement, double replacement, synthesis, decomposition, neutralization, and combustion. And then based on the chemicals that are in there as a post-lab activity, you're going to have to try to write a balanced equation and explain everything that you saw. So for station A, what we are going to do is we're going to use some test tube holders. We've got a little bit of calcium carbonate powder in a test tube. Calcium carbonate is just chalk. If you've ever seen a gymnast or a rock climber put their hands in, get that chalk on their hands, that's all this is. And we are going to heat this up over a Bunsen burner. So I'll light my Bunsen burner. And we do not want an orange fire. We definitely want a hot turquoise fire. So I'm going to twist the neck. And I'm going to keep going. So all the orange is gone, but it's not hot enough. I'm going to twist until I can see a turquoise cone form in the middle. The hottest part of this fire is the tip of the turquoise cone. So now I hold this with the test tube holders, and I'm going to heat it for 1 to 2 minutes over this Bunsen burner, right in the tip of the turquoise cone. When I'm heating something over a Bunsen burner, I want to make sure to move it back and forth, and I want to make sure that it's at an angle. If there were other people in the room with me, I would also want to make sure that I wasn't pointing the test tube at them. The reason I hold it at an angle is because right now the chemical, the white powder, is over the fire, but the test tube holder is not over the fire. And what that does is it allows the Bunsen burner to really heat up that white powdery sample, but the test tube holders aren't getting hot. Because as you know, metal conducts heat really easily. And so if I had it vertically, the test tube holders would get warm as well and start to burn my fingertips. So I just move this back and forth. And it's 1 to 2 minutes. It's not a quantitative amount of time. Basically, we need to heat it up enough that that heat is clearly going to be doing something to what's in the tube. It doesn't look very different, but if it's in this lab, something must be happening. So what we're going to do now that it's been about a minute, is we are going to take a wooden splint and we are going to light it on fire. Where is my wooden splint? I'm going to get a wooden splint and then I'll be right back. All right, so I've got a wooden splint. I'm going to light this on fire. And so I'm just going to move the test tube out of the way, put the wooden splint in there. And now I'm going to take the wood splint while it's on fire and I'm going to slowly insert it into the tube. And then I'm just going to notice what happens. And so as I start to move it towards the tube, you can see the fire starts to extinguish. If I pull it back out again, the fire lights. But if I put it in the tube, it extinguishes. And so this process right here is called a splint test. You're actually going to do it quite a bit in chemistry class. It tells you what kind of gas is formed. If oxygen gas had been produced in this reaction, what we would see is that flame would have grown and gotten a lot bigger because hopefully we know from somewhere in our past experience that oxygen is necessary for a fire to burn. But if the fire extinguishes like that one did, what it tells us is that carbon dioxide gas is present. CO2 extinguishes the flame. And so since that splint went out, we know CO2 is present. It's called the splint test. So I'm going to turn off my Bunsen burner now, make any final observations I need to. It still looks like a white powder. And so the flame went out, that's one observation. It still looks like a white powder, but what I will say is there's still some powdery substances at the top, but it is a solid chunk at the bottom. So it's still white, but it's kind of condensed and formed a hard block at the bottom. All right, so that's it for station A. For station B, we don't need the Bunsen burner. I'm just going to slide that off to the side. For station B, we are going to take copper chloride and aluminum. And so first thing I'm going to do is I'm going to take 2 pipettes full of copper chloride solution. So when we say 2 pipettes, this works kind of like a turkey baster. It's not a quantitative amount. It's just 2 big squeezes. We want enough chemicals so we can see what's happening, but we don't want to create a ton of waste. So there we go. 2 nice squeezes of the copper chloride solution. You should note that it does have a color, but I can see through it right now. So it reminds me of Windex. Something for you as you're writing your observations just to pay careful attention to. If you can see through a solution, it is clear. So water is an example of a substance that is colorless and it is clear, but this substance is blue and clear. So clear doesn't necessarily mean it looks like water. Clear just means you can see through it. The opposite of clear is opaque. So this is blue and clear. And then we're just going to take a little chunk of, this is just aluminum foil that I crumpled up. And I'm going to plop it in there. And then I'm just going to wait and see what I observe. And what I can see starting to happen is there are bubbles forming. And the aluminum foil seems to be changing color. Like it looks like there's some kind of rust coating that's forming on the outside of the aluminum. All right, so I've got some bubbles, I've got some color change happening, I've got some rust forming, and I'm actually going to move on to station C, and then we're going to come back and we're going to look at all 6 stations at the end once we're done. So station C has got some different chemicals. Station C, we've got calcium nitrate, and so we're going to get 2 pipettes of calcium nitrate. And calcium nitrate, just to take note of, it is a clear solution and it's colorless solution. It looks like water. And then I also have some sodium carbonate solution, which is also clear and colorless. But when I mix these 2 clear colorless solutions together, I'm going to add the second pipette. We don't really need it. We can see what happened. So it's not clear anymore. It is definitely opaque. So the reason we can't see through it anymore means that a precipitate formed, and the color of it tells us it was a white precipitate that formed. All right, and that's it for station C. All right, so for station D, this one is actually the most dangerous one because all of the chemicals we use are corrosive or flammable, so we want to always make sure we exercise caution. So we're starting with hydrochloric acid, which is a clear colorless solution. I'm going to get 2 pipettes of hydrochloric acid. Now, for the phenolphthalein that I'm adding, if you pay careful attention to the directions, I'm not going to add a full pipette of phenolphthalein. I'm just going to add a drop or 2 of phenolphthalein. Phenolphthalein is a substance that changes color based on the pH, and so since I put it into an acid, I didn't see any color change happen, but that's because it's an acid. As I add this other chemical, sodium hydroxide, which is a base, we should see something happening. And so I'm going to get 2 big squeezes of sodium hydroxide. Oh, saw a little bit of a color change. There it is. All right, and so that color change right there tells us that the pH of the substance changed. But if you notice, you can still see through it. It is pink. It is definitely pink, but it is still clear, meaning there is no precipitate in there. I don't know if you guys can see it, but I actually got a little drop of phenolphthalein in test tube C. So test tube C is going to go from white to pink in just a minute as well. That was a mistake. That shouldn't be happening. But what that does tell you is that something in test tube C must have a slightly basic pH. All right, station E, we're actually not going to mix in a test tube. We're going to grab the Bunsen burner again. And station E, the warning on station E is you shouldn't look directly at this thing when I light it on fire. You're going to. I do it as well. But technically, the directions say do not stare right at it. If you've ever looked right at a light bulb or looked directly at the sun, it causes that spot in your vision for a moment. Magnesium they actually put inside road flares and the really bright white lights when you're doing fireworks, like the really bright ones. So this stuff, when you light it on fire, just glows really brightly. So don't stare right at it. Kind of glance off to the side if you can. But we are going to light the Bunsen burner. And we want it to be really hot, so we're going to make it turquoise. All right, now we are going to get a piece of magnesium, and I'm going to hold them in these tongs, and I'm going to just pinch it right at the very end, so as much magnesium as possible is exposed to the fire. All right, and then we're going to put the magnesium right into the tip of the turquoise cone. Now, this is a self-propelling reaction, so once it gets caught, I'm going to remove it from the fire. You don't have to leave it in the fire. Once it's started burning, it will continue burning. And so, there it is. And so even though I'm not looking directly at it, I can see it is glowing really brightly. So energy, I don't even know, that's not even a sign of a chemical reaction. I guess the color of the air changed. But look at the end. At the beginning, it was these silvery chunks of metal, and now it's just this sad white powder. So it was definitely a color change that happened from silver to white, and then that glowing that happened as well. You guys can probably accurately predict that if something is on fire, it's getting hotter. So the temperature change definitely happened. But that's it for station E. All right, now for our last one, we're back in the test tube again. We are going to take a little bit of hydrochloric acid, and we're going to put it in this last empty test tube down here. And so we're going to get 2 pipettes of hydrochloric acid. And then we're going to add 1 piece of solid magnesium. This is actually the same stuff I just lit on fire, but it's going to react very differently with acid than it did with the oxygen that was in the air. So if I plunk that down in there, it starts bubbling pretty rapidly. And so there are definitely a whole lot of bubbles that are forming. So formation of a gas. All right, while that one is fizzing away, I'm going to go back through and just walk all the way through stations A through F one last time so you get any final observations. The observations you write down in your data table are going to be super important when you go to try to write your balanced equation. You're going to have to include a state of matter with everything. And so these observations are how you know what states of matter everything was. So make sure you're paying attention. So in this test tube, it's still a white solid powder at the end. So it is definitely still white and solid. In this test tube, we've got the aluminum foil that's still there, but there's a pretty significant layer of orangish reddish solid that is formed right where the aluminum foil on the bottom comes into contact with the blue liquid. And it's still bubbling a little. Not a tremendous amount, but there are still some bubbles forming in that test tube. But the aluminum is still there, and the color of the solution is still blue. All right, this one, station C. Again, try to ignore that pink color. I made a mistake and put a drop in there, but that is very much just a white precipitate that is in there. So it is white, it's color change, and then it's also precipitate that's formed. What that means is one of your 2 products was a solid. Then on this one, we've got a pink color that occurs. And so color change, that pink color, remember, we use phenolphthalein, so you know it tells you something about the pH at the end. Station E, I just kind of wiped it up, but station E is all this white residue that's all over the desk. Station E was definitely just a white powdery substance at the end. And then station F, now that we've bought it a couple of minutes to react, station F, the piece of magnesium I put in there is almost entirely gone. So I'm going to guess if we let it sit for another couple of minutes, it will be entirely gone. And so what that means is the products of that reaction, there are no solids as the product. You know, one of the products is a gas because it was bubbling. But the other products, there can't be any solid because that thing's going to be gone soon. And so that is the types of reactions lab. And now you're going to have to try to figure out which ones are which types and then write a balanced equation for each.